This is a presentation about J. Robert Oppenheimer, from theoretical physicist to the Manhattan Project. So, Oppenheimer's early life and education. J. Robert Oppenheimer was born in 1904 into a wealthy and cultured New York City family, which meant his childhood had a bit more Shakespeare and a bit less street ball. Even as a kid, he was an intellectual powerhouse, basically. He was reading Plato and studying mineralogy for fun, while most of us are still figuring out how to spell geology, or most of us during his time. He zoomed through Harvard in just 3 years, majoring in chemistry, though physics quickly stole his heart, and he wasn't content with just American education either. He quickly headed off to Europe to study under quantum theory legends like Max Born and Werner Heisenberg. Imagine being in physics class where everyone is literally rewriting the laws of the universe. That was Oppenheimer's graduate school experience. I mean, no pressure, right? He also got his PhD under Max Born, and that is where he also worked alongside top physicists in quantum mechanics. His academic career. Once he got his PhD, Oppenheimer came back to the United States and joined the faculty at UC Berkeley and Caltech, because teaching at one top tier institution just wasn't enough for him. He dove deep into quantum mechanics, quantum field theory, and astrophysics, sometimes all in the same week, maybe in the same day. His lectures were fast, dense, and philosophical. Students said that he could make even the most abstract equations sound like poetry. That said, he was also known for being intense. He wasn't the warmest professor, and definitely not the easiest grader, but he was one of the most brilliant. He cultivated a sort of mysterious genius vibe, quoting Sanskrit and pausing mid-lecture to ask rhetorical questions about the universe. He also had some ties to left-leaning political movements, which weren't especially controversial at the time, but they'd come back to bite him later. He mainly focused on quantum mechanics and astrophysics, and yeah, he mentored many young physicists while he was there, or during his time at Berkeley and Caltech. Political climate and World War II. The Obviously, because this had a massive impact on everything that happened afterwards. So the late 1930s and early 40s weren't really calm times, with Hitler rising in Europe and whispers of Nazi nuclear ambitions spreading through the scientific community. Physicists suddenly found themselves in high demand, not for academic conferences, but for national security and weapons development. Alarmed by what they knew about uranium chain reactions, Leo Szilard and Albert Einstein co-wrote a letter to President Franklin Roosevelt, warning that Germany might be developing an atomic bomb. Roosevelt read the letter and went, "Alright, time to open the checkbook." Thus, the Manhattan Project was born. This marked the first time theoretical physicists got military funding in huge amounts and were told to just go ahead and rewrite the rules of matter. Just do it before the Germans. No pressure there either. And who else but to lead it other than Mr. Oppenheimer himself? And despite having zero managerial experience and, probably struggling to organize himself, Oppenheimer was chosen to lead the scientific effort of the Manhattan Project. He was chosen because he had the brain of a theoretical physicist and the rare ability to translate between sciences. Engineers, military brass, chemists, physicists, mathematicians, he quickly fit into his leader role. And he was fluent in all sorts of mathematical speak. He set up shop in Los Alamos in New Mexico, remote enough to be secret, dusty enough to make brilliant scientists uncomfortable, and just weird enough to work there. There, he assembled the Avengers of the 20th century science: Fermi, Feynman, Bohr, and many others. His job wasn't to solve every problem himself. He was the conductor of a very explosive orchestra, and through leadership, caffeine, and insane amounts of chalk, he got them to make history. The internal workings of a nuclear bomb. So, this is the physics part of the presentation. So, a nuclear bomb works by using nuclear fission, which is when a large unstable nucleus, such as uranium 238 or plutonium 239, are split into smaller pieces. Then these split pieces release an extreme amount of energy and a few extra neutrons, which then hit other smaller parts of the plutonium or uranium, and then those split, repeating the process until there is nothing left. And that happens at a million times per second, or a really long chain reaction. But the trick is getting through enough of the material in one place fast enough to make it happen. That's called reaching critical mass. To do that, engineers surrounded the core with high explosives to compress it inward instantly. It's like trying to get a room of hyperactive particles to sit still by slamming the doors shut with dynamite. By basically sealing off all space between whatever was outside of the casing and whatever was inside, they limited the explosion, but obviously atomic bombs are still massive, so it doesn't really work. So we have the fissile core, which is the plutonium and the uranium, the neutron initiator, which is sort of a bullet. It is a hollow tube that is sent towards the sphere, which then ignites, air quotes, ignites the chain reaction, and then obviously the explosives. The radio trigger is used as a sort of either a failsafe or as a pre-detonation tool, and the fins are often used to guide, or in modern technology, they are used to guide missiles or bombs to specific locations. But back then, I think it was just to make sure that the bomb traveled to where it was supposed to land, or where it was calculated to land. So, types of nuclear bombs. So, we have two types, which is the gun type and the implosion type. So, the United States ended up creating two main types of nuclear bombs. The little boy bomb dropped on Hiroshima, which used uranium and a gun type design, where two subcritical masses slammed together, which is sort of like using the bullet, the hollow tube, except instead of a hollow tube, it is another subcritical mass. Essentially, it fired one chunk of uranium into another at high speed, like bumper cars basically, with catastrophic consequences. Then there was the Fat Man bomb, which used plutonium and a much more complex implosion design. Plutonium is more temperamental than uranium. It is way too unstable for the gun method, so they surrounded it with a series of explosive lenses to compress the core evenly from all sides. It was like squeezing a balloon made of plutonium with carefully timed fists of TNT. Getting that to work required a lot of math, a lot of testing, and a lot of scientists, which probably had a couple breakdowns trying to design this thing. And the Trinity test. On July 16th, 1945, in the desert of New Mexico, Los Alamos, the first nuclear device was tested in an event called Trinity. The scientists had no idea what to expect. Some thought the explosion might ignite the atmosphere and kill everybody and everything. Others brought sunscreen, thinking or believing in the science itself. And when it went off, it lit up the sky brighter than the sun and created a fireball that turned sand into glass. People watching from 10 miles away were blown back by the shockwave, and those were the lucky ones. Oppenheimer For the philosopher, watch the explosion and recall the line from the Hindu Bhagavad Gita. Now I am become death, the destroyer of worlds. Which is probably not something that you want to say unless you're watching the literal dawn of the nuclear age. So I think you picked a pretty good quote for that. And this was equivalent to 16 or 18 kilotons of TNT, which is a lot of TNT. Legacy and ethics. After the bombings of Hiroshima and Nagasaki, Oppenheimer went from the brilliant project leader to the conflicted moral figure. He met with President Truman and told him he felt like he had blood on his hands. Truman, definitely not in the mood for an existential crisis, allegedly called him a crybaby and sent him out of the room. Oppenheimer became an advocate for arms control and strongly opposed the development of the hydrogen bomb, which made him unpopular with the increasingly paranoid United States government. In 1954, during the Red Scare, he was accused of being a communist sympathizer and stripped of his security clearance. It was one of those moments in history where politics steamrolled science. Oppenheimer faded from power, but his voice and his cautionary legacy never went away. This is why we have agreements in the modern age that are limiting the amount of nuclear weapons that countries are allowed to have. Countries such as Russia and the United States were to demilitarize or disable many of their nuclear weapons for the mutual safety, except I think that both countries still have over 7,000 nuclear bombs combined, which is more than the other top 20 countries combined as well. So, it surely worked a little bit, but yeah. Conclusion. So, Oppenheimer's story is not just about physics; it's about genius, ambition, and the terrifying consequences of asking, "Can we?" without always asking, "Should we?" He helped bring an end to a brutal war, but in doing so, introduced a new kind of fear to humanity. He took the cat out the bag. And the thing is, with this cat, is that you can't really put it back. His brilliance changed the world, but also haunted him. Today, he's remembered as the father of the atomic bomb, a title that carries a lot of weight and no small amount of regret. His life reminds us that science doesn't exist in a vacuum. It lives in the real world with all its messy politics, emotions, and fallout, both literal and philosophical. But at least he had a movie made after him. Am I right?